and good evening to those to the east and good morning to those in the west. Today, we're going to start with our webinar for aviation blended learning environments, and we will cover a lot of ground. I want to welcome everybody to this webinar. We have 42 attendees right now, and we might have a few more join us as this webinar proceeds. We look forward to having a very interesting and engaging hour with you. We will speak about a lot of different topics, the foundation of aviation-blended learning, and we will move through the presentations toward how it will be implemented. We have a lot of participants. For an orderly proceeding, I ask a few house rules. Please keep your microphone muted. Your webcams should be disabled. If you have any questions for the Q&A, ask them via the chat. We're going to collect these, and then during the Q&A, we'll be able to post them to the respective panel members. For the speakers, when we have the panel discussion, the Q&A, please turn on your webcam then so that everybody can see the panel. This webinar is going to be recorded as well. If you were watching this on a mobile device, it might be that the presentations, which will be in the form of video, that you might need to press the play button. If not, for most people watching on a desktop, it should play by itself, and you should be able to enjoy the webinar as it stands. I have the honor of introducing our first speaker today. That is going to be Captain Philip Adrian. He might be familiar of us, for most of us. He's currently the CEO of simulation manufacturer MPS, Multi-Pilot Simulations. He's also the chair of the Rulemaking Task 0599, a member of the training task force of RMT 0196. Sorry. He's qualified as an instructor on several aircraft, including the 737, 777, and 78. And he's previously also held management positions at airlines and at Boeing. He will introduce the RMT group and their efforts today. He will provide an introduction for the concept of aviation blended learning, and he will also provide the introduction of the first presentation of Andy Mitchell. So, without further ado, Philip, if I can invite you to turn on your webcam and join me up here and kick off this webinar with your introduction.
Thank you, Frederick, and welcome everyone. As introduced, my name is Philip Adrian. Maybe we have discussed this before. I am the chair of Rulemaking Task 599, where this found its inception. I don't want to take too much of your time, and contrary to popular belief, I believe we can do something without slides. I just want to identify the history of this this effort and the participants, and then introduce Andy. Rulemaking Task 599 is responsible for performance-based rulemaking, and as such, we have looked into many items of EASA regulatory issues. One of the things that we found is that training needs to turn into learning, and how do we do this, and how do we get out of the rut of we have always done it this way. So we had the assistance of especially Anneke Nabben, Andy Mitchell, and others that possibly go unnamed but had contributions to identify a new way of learning and support of the learning, which is generally identified as task-to-tool approach. The aviation blended learning environment is supportive of what is done in ICAO document 9625 with regard to the what it was called the simulator DNA, now is called the FSTD capability signature. And we have tried to prevent getting into the same issues as we had in the history by allowing a process rather than device qualification to support this. That process is called capable, the comprehensive analysis process for aviation blended learning environment. And in that process, and Anneke and others will come to that later, in that process, we should be able to identify a combination of existing and new devices or tools to reduce dependency on individual tools and integrate a whole blended scope of tools that support the learning and is task to tool. So with that, I'm not going to take much of your time. I want to introduce Captain Andy Mitchell. Besides being a personal friend of mine, he is also currently the CEO of aviation software company Use Before Flight and an advisor on the rulemaking task 599 and a founding member of the IATA EBT core group. And he's current as a TRI on the Airbus A320 family, has over 10,000 hours on type, and is a very, essential part of this whole thing. So with that, Andy, take it away.
Well, a very good afternoon, ladies and gentlemen. It's really great to be here today, especially as I get to speak about one of my favourite subjects, aviation blended learning environments. I want to take about the next 10 minutes to build on Philip's introduction and provide you with some food for thought about what we need to consider as we move towards this next chapter in aviation training by embracing new technologies. Computers are now 1 trillion times more powerful than when we first landed on the moon, and this increase in power is just going to continue into the future. In fact, the iPhone 11, which, like myself, I'm sure many of you have in your pockets right now, has got 1 million times more power than the computers of Apollo 11 that took Neil Armstrong and Buzz Aldrin safely onto the moon. Sticking to the theme of the moon, I'd like to start by sharing with you one of my favourite stories of the space race, which I think really sets a scene with what we're talking about today, a successful implementation of blended learning into our industry. During the space race, NASA had, of course, many challenges to overcome, and one of them was the issue around the astronauts writing notes in zero-G. Normal pens don't work without gravity. They spent around $10 million in today's money creating a brand new high-tech space pen that worked in zero-G and at all temperatures. The Russians, of course, had exactly the same challenge, but they came at it with a completely different approach. They used a pencil. So why did NASA take this over-engineered route? It's because they came at the challenge with a predefined solution and made it fit the problem. What they should have done is ensured they started with really defining the problem and an open-minded view to the solution. This is where we can be really smart and is exactly what we need to do when it comes to aviation blended learning environments, ABLE. Here's the space pen and pencil on a graph of function versus cost. It doesn't matter that you pay more, you get exactly the same function. If we now look at aviation training, I firstly want to change the wording from cost v function to exclusivity versus fidelity, just to make sure we are aligned that this is about increasing accessibility to higher quality training programs and not just about cost reductions. We traditionally have a graph that looks like this: a low cost, easy access whiteboard at the bottom left and a full flight simulator at the top right in terms of high exclusiveness and high fidelity. But firstly, is this graph static? And also, what about that big area in the middle where there's nothing there at all? Can this graph ever represent the space pen and pencil? Well, it depends on the problem, the task that you want to solve. A classic example of this, and really a bit of a space pen moment, was during my own type rating. During one of the sim sessions, the instructor turned off the motion, turned off the visuals, and turned off the sound, and they started giving us training on how the radio panel worked. They were under enormous time pressure to finish and move on to other activities in the sim syllabus, which of course we also then felt the pressure of. We were sitting in a full flight simulator, only working on our application of knowledge and application of procedure competencies, 2 out of the 9 competencies. So, if we go back to our graph, for this task, we actually only require a lower level of fidelity, so the simulator actually sits further down on the graph. So, what if we now draw a line across, and at the intersection, we find a new technology solution that provides the same level of fidelity for what we need for this particular task? This would now allow us to complete this task in a lower fidelity device and use the full flight simulator for only the tasks requiring the highest fidelity and exposing us to all the competencies simultaneously. So, we can now populate the graph with more and more new technologies. By the way, the red ones on here are of course the space pens. They're the ones we want to avoid. High exclusivity and low fidelity. But if we start with the problem and then look at the possible solutions based on fidelity, we can then create a blend of new technologies that don't just provide cool eye candy, but they provide an effective, efficient, and future-proof training pathway for all our pilots. By the way, the space pen story is actually an urban myth, but hey, why spoil a good metaphor with the truth?
Thank you, Andy, for that insightful presentation. And I think that's a very nice introduction for our next speaker, Anneke Nabbe. She will take this your idea forward and provide a more in-depth account of how the capable process will work. Anneke Nabbe is a senior training expert at the Netherlands Aerospace Center. She's also the main author for the Blended Learning Environment concept paper, which is published by the 0599 rulemaking task. She's been involved in a lot of training projects in both the civil and the military domain, and she has held positions at both KLM and Airbus in their training departments in the function of training expert. And as indicated, she will build forward on Andy's presentation and provide a little more detail into the capable process and how that will lead to better designed blended learning environments. Over to you, Anneke.
As we heard from Andy, there is a lot of cool technology with a lot of big promises, but it's not easy to make a blended learning environment. And of course, it's a big responsibility. So that's why we would like to take you through an example to explain how to put this in practice. The creation of a blended learning environment is more than the acquisition of training media. First, you start, of course, with a training problem or opportunity. And when you have this training problem or opportunity, you can analyze the training needs. If you know the training needs, the training design can be made, and after making a training design, you can select training media that are fitting the training design. If the training design and the media are selected, you can validate this training to see if it answers to your training problem or opportunity. Once everything is okay, then you can ask for an alternative means of compliance in order to be allowed to use this new training design and its media. But if you chose to change something in your training that doesn't go under regulations, of course you can use it as you want. In the following slides we will illustrate this capable process with an example, but please bear in mind that not all the details are accounted for in order to maintain focus in this presentation. To explain the capable process, we would like to take you through a use case of KLM Cityhopper Embraer type qualification training. KLM was using a flat panel trainer to train the ground procedures, and this flat panel trainer was not up to date anymore, which of course means negative training, and they could have replaced the flat panel trainer by full flight simulator, which is actually quite expensive, but also updating the flat panel trainer is very expensive, and that's why KLM was thinking about different training media. But how to do that? Knowing what the training problem is, we can start the training needs analysis, the first step in the capable process. Well, focusing on the initial type qualification of the Embraer and in specific on the aircraft flight preparation, the main objective that we want to achieve is correctly and efficiently perform aircraft startup and flight preparations in various operations that can be expected, using all relevant checklists, call-outs and techniques. And the focus will be on the following competencies: application of procedures, knowledge, problem solving and decision making, and situational awareness. And this will be done under time pressure, hot and cold weather conditions, and engine issues. Because the aircraft flight preparation consists of several items, we would like to focus for this example only on one item, and that is the before start procedure. For the before start procedure, we would like to know what kind of skills and knowledge are important. Well, and the skills are here: button switch operation, which is psychomotor, electronic before start checklist, which is reproductive, and so on. And then there are also some knowledge items, of course, which is the button switch locations, FMS operations, scan flow patterns, and electronic checklists. And we have to make sure that all of this is covered in the training. Having done the analysis, we can start making the design. In the capable process, the design is based on the 4CID model, which is the 4-component instructional model. And this model consists of whole tasks, which is the backbone of the training, and the whole task is an integrated set of competencies and skills that is performed within the operational context. And you can have large whole tasks, but also, of course, you can have smaller whole tasks. So that's why we call it mini whole tasks. And the idea is that you perform this whole task already from the beginning, but then with a lot of support, and that the support will get less and less towards the end of the training. Then there is part task practice that you only use in support of whole task practice to make sure that this doesn't take any cognitive room while performing the whole task. And of course there is supporting theory, and we also make use of just-in-time information. These are the 4 components of the model. Before going further with the example, I would like to put this example once more into perspective of the complete training. Well, the type qualification training consists out of several whole tasks, like flight preparation, taxi, go around, emergency, etc. Then, for this example, we are focusing on aircraft flight preparations, which consists again out of several mini whole tasks, like safety checks, power up, before start, start or after start. And in this example specifically, we focus on the before start procedure. Well, knowing the training needs and the training design elements, we can start making a training design. But please bear in mind that this example does not account for all the details, but gives a good example of what a design looks like. The trainees always start with a whole task here, which is the aircraft flight preparation, in order to put the before start procedure into perspective of the whole task and its operational context. After having performed this whole task, the trainee practices use of electronic checklists so that he can automatically use the checklists when performing a whole task. Then the trainee is going to perform the before start procedure in the context of the operation, and he will get some just-in-time information on visual scanning. Then again, some part task practice of the before start procedure, excluding FMS use, to make sure that he automatically can use this, all the steps in the procedure. Some theory on FMS, and finally some before start procedure whole task training with FMS so that he can use the before start procedures in the context of the task, of the operation. Then we have some aircraft flight preparation other procedures that we are not going to elaborate on in this example. And finally, the trainee ends with the whole task training with context and all complexity factors of the complete aircraft flight preparation. Now we know the training elements that we have in the training, then we can start making user requirements for your training media. And we have different user requirements, that is to say tactical requirements, and we have technical requirements. And in those two categories we can ask a lot of questions concerning requirements to your training media. For example, do you need other crew? Do you need performance monitoring? And if we talk about technical requirements, what aircraft behavior do we want to see? Working in this manner, you get targeted fidelity. So you don't get low fidelity or high fidelity, but per training element, you get the exact fidelity that you need. Knowing the training design, we can start developing using requirements. And for the first whole task, which is the flight preparation, we would like to have a realistic environment in order to show the trainee the complete operational context of the task. And for the before start procedure, for example, we would like to have a didactical requirement, which is feedback on completion. And if we look at the final mini hall task of the before start procedure, we would like to have the FMS functionality in order to make the trainee able to practice with the FMS. And of course, we have to do this for all elements in the training, as you see at the gray arrows, but we didn't elaborate on everything because this is just an example. Now we can start selecting training media. For the first whole task, aircraft flight preparation, the trainee watches a video to make sure that he can place the before start procedure within the context of the whole task and the operation. Then the trainee is practicing electronic checklist use, and for this he uses a poster and of course the electronic checklists. Then the first mini hall task with some just-in-time information on the visual scanning, a VR goggles is selected. And for practicing the before start procedure, also a VR goggle is selected in which he can automize the skill. Then theory on the FMS with an iPad. And finally, a flat panel trainer for the before start procedure with use of the FMS as a whole task, as a mini whole task. And finally, after also having done all the other parts of the aircraft flight preparation, the trainee will integrate all these mini hall tasks in a full flight simulator. And this process works because we connect the training media with the design of the training. And by taking a more detailed look at our training design, we create space for proper integration of new technologies in a responsible manner instead of simply bolting them onto an existing program. Here you see two pictures of the KLM VR tool that they developed to integrate in this blended learning environment. And if you look at the right picture, you can see also some just-in-time information. There are several considerations to take before actually implementing the ABLE, and this also echoes what Andy Mitchell was saying about the quality requirements for training devices. The things you have to consider are the soft and hardware standards, like ISO, and also you have to take into account the security and privacy standards, which are a big thing nowadays. The integration within the organization and the infrastructure, like buildings and networks, have to apply towards the ABLE environment. And also, if future operations change, you need to be able to update your training media. And finally, if future technology evolves, then you want to make sure that you can go with this evolution and make use of latest tools. Also, validation is important, and this will differ from ABLE to ABLE. First of all, the training validation. Does it deliver equal or better training, this ABLE environment? And for the technical validation, it is important to know if this ABLE is really reliable, especially in a busy, high-paced training program. Also, it is important to make sure that instructors can work with this ABLE environment, but also the support personnel needs to be able to work with it. And of course, not unimportant, cost validation. What does the ABLE cost to keep alive, and is this manageable? Well, finally, after developing and validating the ABLE, the capable process is complete. And approval must occur. And currently there are two ways in doing this. Well, no prior approval, which is the case for the KLM example, in which it was on extra training. Or you ask for an alternative means of compliance, when it's not extra training, but regulated training. And this means that you have to take a difficult path involving challenges like CFSTD standards and requirements. And therefore, the ultimate goal of EASA is to introduce an ABLE acceptable means of compliance, which supports innovation in ABLE by relying on a solid capable development process. And Julian Colinius will talk more about this. In this presentation, we only give the example of the KLM ground procedure training. But of course, there are many other examples to give that also go beyond pilot training. And a few examples are maintenance training, or pushback training, cabin fire training, or for pilots, the HUD device training, or CAT-C aerodrome training. But they have one thing in common. They all have to rely on a solid development process, which is called capable. So let me conclude with the main takeaway of this presentation. It is imperative that training media and training design are fully integrated, instead of training media being bolted onto existing training. And this is in essence what the capable process is doing.
Thank you, Anneke, for that presentation and to take us through that process. As you've indicated, this is a process that looks easy, takes a lot more time, but it's a process that also, of course, provides that robustness that we need to be able to introduce these technologies responsibly. This leads me to the last speaker for today. The last speaker of today is Julien Colinos. He is a flight crew training expert at the Flight Standards Directorate at EASA. He has an EASA ATPL and FAA ATP. He's been involved in pilot instruction for over 25 years in both the EU, but also the US. We're very excited that Julien has made time to represent EASA today in this webinar. He will be presenting about the agency's approach to accrediting these new training technologies via the ABLE philosophy, and will provide a more a perspective on implementation of the processes that Andy and Anneke have been explaining. Julien, over to you.
I'd like to start with a warm thank you to MPS and NLR for organizing this event. I will present a concept bridging blended learning and the FSTD capability approach. We all know that blended learning is a multi-channel method that is incorporating tutor-led activities, instructor-led, pictures, videos, digital tasks, virtual aircraft, self-study. We have all these new virtual technologies that are becoming more and more familiar to us in all aspects of our lives. And we see blended learning as the perfect instructional model for experimenting with these new technologies. Some training courses are already incorporating these technologies, bringing new experiences in learning. I would like to emphasize that I'm talking about the practical part of the training, because on the theoretical part, we all know that we've been from instructors reading the FCOM to the VACB a long time ago, and then CBT and WBT. So this is already done in the theoretical part. Actually, we are in a hybrid stage, meaning that there is a combination of the old technology and the new technologies. And this combination already presents a strong innovation compared to the old technology alone. What we're looking to do by enabling these other training devices and tools is to promote simpler and less expensive training aids. When I'm speaking about other training devices and tools, OTDs, I'm mostly addressing non-qualified devices. And there is a lack of requirements addressing these devices in practical training, as there is no EASA guidance available, there is no harmonized approach amongst the NAAs, and we need standards to ensure consolidated outcomes of the evaluation, whichever the NAA is. The training providers usually plan a simple solution to start with, let's say virtual reality goggles, and then gradually increase the range of virtual reality and augmented reality solutions to more complex systems. This could result in continuous workload for the national aviation authorities, and this over a long period of time, maybe years. The challenge we face is to establish common requirements for the multiple approaches and for the constantly evolving technologies. So we need to come up with flexible requirements that will be adjustable and proportionate to the complexity of the technical solution in order to assist the training providers in defining the appropriate use of their tool and also to support the competent authority in performing the evaluation. And this is where the FSTD capability signature approach comes into play. We foresee that the best approach for evaluating these non-qualified other training devices should be a natural evolution of and similar to the FSTD capability signature approach that we're using for qualified devices, and in which we have defined the method and we are acquiring some experience. This is a rulemaking task done by the agency under 0196, and it's for the evolution of the certification specifications of the FSTDs. But first, we need for each training item to identify the required simulation features and the needed fidelity levels for attaining the associated learning objectives. We define the learning objectives by using training need analysis, TNA. Then we have to verify the capability of the planned new technology solutions to meet the necessary simulation features and required fidelity levels. To do that, we need to evaluate the suitability of each proposed other training device training solution, hardware and software combination, against a set of standards that we still have to define. And we have to see how the other training devices will be integrated and coexist with traditional flight simulators into the training program. So we'll just go in some additional details on the process. We start with the TNA to break down a complex task into simpler subtasks, and each subtask with a well-defined objective. Specify for each subtask the skills needed to assimilate the subtask and the minimum levels of fidelity that are required to reach the learning objectives. We have a complex task. We break it down in multiple subtasks. For each of these subtasks, we define the learning objectives, the required skills, and the required fidelity levels. On the other side, we have the FCS. The FCS defines 12 flight simulation features that concern the aircraft, the flight deck, the flight model, ground handling, the systems, flight controls and forces, the external cues, sound, visual, motion, the environment. And for each of these features, we have 4 fidelity levels. The lowest one is none. None is required. Generic is the lowest level of fidelity. Representative is the intermediate. Let's say representative will be a twin-engine cockpit, Airbus. And the specific, which is type-specific, Airbus 320 family. Then we associate the learning objectives defined for each task to the FCS, the simulation features, and the required fidelity levels. So how do we see this process at the agency? We see it in 2 parts. One is addressing the device manufacturer, and one is addressing the device user. The device manufacturer will apply to EASA for the review of his training solution compliance against a set of standards. EASA will issue a review outcome to the device manufacturer, and then the device manufacturer can circulate it to the training provider using his device. This, we hope, will ensure a harmonized approach at member state level. The training provider will then apply to his national authority using the outcome of the EASA review, but also he has to substantiate and demonstrate to his national authority how the training objectives are met with his device. And the national authority will issue the final approval for training for the device. EASA involvement in the process would be on request by the device manufacturer if he wants to assign some training credits for the practical part of the training to his device. The statement of EASA review of the training solution will be a compliance against a set of standards that we still have to define, stating that the training solution, hardware and software combination, as evaluated, satisfies the EASA standards. Then the demonstration of the device adequacy as meeting the training objectives that have been defined through the TNA in a training course, and the compliance with the regulations remains the responsibility of the training provider, the final user, and their competent authority will need to give the approval for training for using this device in a training course. How do we see EASA's role in the process? First one will be to harmonize the approach used by the national aviation authorities to approve the use of these new training technologies and methods. Then we have to ensure that the training provides at least an equivalent or best level of proficiency. We have to facilitate a level playing field for the device manufacturers and for the device users. and we have to continue harmonizing with ICAO. We are following ICAO guidance to come with our own set of standards. The applicability we foresee is, of course, for the pilot and cabin crew, but also for maintenance and for air navigation services that can be very beneficial, for example, in replacing a control tower simulator. I hope that was clear enough for you, and I thank you very much for your attention.
Thank you, Julien, for clarifying the EASA's perspective on this and to provide an outlook into how this would proceed in a more practical point of view. That actually also closes the presentation part of this webinar, and we will proceed to the Q&A. And there's an opportunity to engage with a fairly large panel of experts about this development. And I would like to actually invite all the speakers and panel members to put up their webcams so we can all see you there and we can actually form a panel in this digital age. I'd also like to introduce, of course, all the speakers which have already had an introduction and supplement this with two other panel members. We have Francisco Arenas Avrino. He works at EASA as a project manager of several tasks, a man with many fingers and many pies. RMT 0.0599, focus on ORO-FC and evidence-based training. Also the RMT task 0.0379, weather operations, and RMT task 0573, fuel planning and procedures. He is currently a TRI on the Airbus A320 family with over 10,000 hours total and 5,000 on type. And I'd also like to introduce him. We are very happy that he can make it for us today. Representative from KLM Cityhopper, Ernst Montier. He is first officer on the Embraer and senior instructor at KLM Cityhopper. He is also product owner of the Embraer VR cockpit trainer, which has been introduced by Annika. And for him, I also have a first question for the Q&A session. I'd like to ask him, Ernst, with the introduction of this aviation blended learning environment, and particularly the VR training environment into your training, you've changed, of course, the type rating course to some extent. What future opportunities do you foresee for a further evolution of your training program at KLM Cityhopper?
Yeah, thank you, Frederik. And well, first of all, thanks to all the speakers before me with some very interesting ideas and talks. So within KLM Cityhopper, we've just recently introduced the virtual reality headset. And with that headset, like Annika explained, we're trying to take some ground procedures away from the simulator and train them from home, actually. So it's also a form of remote learning where people can train from home. With that, we now have a basic way of training these procedures, also in a multi-crew environment where a digital pilot, we call him autopilot, is taking procedures from the other seat, so people can really train on their own from home. Looking to the future, well, I think the possibilities for virtual reality are huge and endless. So things we're looking into now is, first of all, incorporating in-flight procedures. We're looking to remote learning. We're already doing the pre-flight inspection training from home. And what we really would like to look into is voice commands. For example, with having a digital colleague next to you and being able to actually controlling that colleague with voice commands, completing checklists with that digital colleague, and even maybe multiplayer where two people can train from home for those procedures that require low fidelity, but people can train whenever they want, wherever they want, as many times as they want, together with their crewmate.
Great. Thanks for clarifying. It sounds like you guys are starting up initiatives in a lot of different areas, and that one thing is triggering also another development, which of course is a positive development into exploring and trying out and seeing what is working. I'd also actually like to pose another question to Julien Coulinos of EASA. Julien, would you be able to indicate how far along is the accreditation project right now? And maybe looking forward, when could an applicant expect to be using those new regulations for accreditation?
If we're speaking about qualified devices, FSTD, it's quite well already we are at work package 3, and we expect to have something during 2021, early 2022. For the non-qualified devices, this is an activity that started about 6 months ago. And even though initially we wanted to address pilot training, we found that the regulation for pilot training was a little bit too strict. And we are now initiating with the cabin crew, where we have a lot more space to move. If we're looking for rulemaking, this will come probably not before 3 years. The thing is that we don't know still if we have to come up with some hard rule, like certification specification for these items, or if we can go with something lighter, let's say a letter of no technical objection that will be used by the training manufacturer, handing out to the training provider, and the training provider will use this letter to convince his national authority, because this is the main not problem, but challenge we have right now, is to be sure that each national authority will give the same attention to this new technology. If you look at what is going on right now, you have some authorities that feel more confident on their knowledge and on their ability to give credits to these new training solutions. And you have some let's say, less confident national authorities that will rely only on regulations and will be a lot more reluctant in accepting an alternate mean of compliance. So we still at the basis, the definition for non-qualified devices. For qualified devices, RMT 196 is working very hard on this. And I think that Philip can also give his insight on this.
Philip, do you want to tag on to that?
Yeah, absolutely. And as Julien well identified, there is a broad scope, and the further we go into this, we started this about 3 years ago with Rulemaking Task 599, which was at that point in time only looking at the pilot side of the house. And we have seen the scope expand and extend, rightly so, because everywhere training takes place, we can do a better job incorporating a better task-to-tool analysis. In 196, we're looking at it from both a technology perspective, so what has to be identified in the certification specifications with regard to flight simulation training devices. So that will lead to an update of CS-FSTD. But we're also looking at it from a training perspective. There is a training task force of Rulemaking Task 196 who looks at it from an ABLE perspective and looks at it from a task-to-tool analysis rather than just tools and specification of the tools. And it is important to keep on looking at that because quite often we find one golden nugget, and a great presentation by Anneke on what has been done with Ernst and KLM Cityhopper. But we have to be careful that we're now not identifying VR as the next full flight simulator and look for problems that can be solved with a solution that we already have. We have to stay true to this process and make sure that everything that we do, every new training that we identify, every competency that we want to address is done properly. So rather than saying, we now have VR, let's see what we can do with it, that is the wrong approach. We need to keep true to the able process and the capable process and look at it from a bottoms-up approach with a training needs analysis and then identifying the proper tool for the task. So I want to keep on pressing on that. And it seems minor, but the intent of Rulemaking Task 599 in this whole thing was to not close off the regulation the way it has been done previously, and identifying that full flight simulators can do everything, therefore they're the solution for all problems. We need to be future-proof. And if we would have this rulemaking task established in 2000, nobody would have thought that the iPad would be a significant part of training as it is today. And we cannot necessarily, as aviation training experts, foresee what is done on the other side in medical, in nuclear, in universities and stuff like that. So we must remain flexible now and in the future for new technologies and new innovations to prove themselves into the training world in aviation training. And when they lead to a similar or better outcome, we must be able to approve those into a suite of training tools of any training provider or airline that needs that.
Thanks, Philip. That actually is also a segue, I suppose, into one of the questions that came up in the public chat. And this is a question I'd actually like to ask to Andy. And it's been partially answered, but maybe, Andy, you can add a perspective to this. There was a question which said, what's better, AR or VR? And how would that pertain to CBT or to FFS steps? And Philip's already indicated to this to some extent, but I think it'd be interesting just to have your opinion on this as well. Do you have an opinion? Is one better than the other in this case? Andy, we can't hear you. Yeah, I think your microphone's off. No, it's still off. And if you get that sorted, I'll set up another question. There's another question that I want to ask to Anneke. Anneke, you've given us an indication of the process. Oh, there we go. Is that you, Andy?
No.
Philip.
While Andy is trying to fix his, I would like to answer that question so that we're not leaving that.
That's a good idea.
And this is Philip. The answer to that question is neither. AR is not better than VR. VR is not better than AR. The training tasks identifies the need, and if the need and the targeted fidelity identifies and the FSTD capability signature can help in that. If the outcome identifies AR, then that is the best solution. If the targeted fidelity identifies VR, then that is the best solution. There is no such thing as a solution for every problem. It is a problem that drives to a solution, and that's what we need to continue focus on. So the answer to the question is neither one is better. They might be better for a specific task, and the capable process will lead to that.
Thanks, Philip. Thanks for picking up that question for Andy. That's very kind of you. That actually leads us to another question that was going to pose to Anneke. So Anneke, you indicated the process of designing, of going into the user requirements, both the didactic requirements and the technical requirements. How does that process look like? How complex is that? Philip already indicated we have to look from the training perspective, from the training need, task to tool. But how much time would that actually have to take? How complex is that?
Well, yes, it's not easy because like I explained, for each training element, you really have to analyze and dig deep into what is really the minimum user requirement that we need. And for example, if you talk about AR or VR, then if a requirement is that you can work together and that you can communicate easily together and that you can also use, for example, real checklists and so on, then most likely AR will be more the outcome than VR, because they're using the real checklists or communicating in a normal way is more difficult. So it's really the needs from what you want to train that decide what the tool is going to look like.
Thanks for clarifying. Another question from the chat that I want to pose to Julien. You might have seen it already. Do you think that NAAs, National Aviation Authorities, realize the need to address these new OTD regulations quickly? Do they think this needs to be expedited in any form? Do you have a feeling for this?
It depends on the NAAs. Some feel that there is a push from the industry. Let's say that the NAAs that have big players under their realm, they understand that there is a need to accept these new training solutions. The more, let's say, remote NAAs, they probably will follow what the leading ones will do. But yes, there is an understanding that this is the way of the future. And again, I'm not focusing on virtual reality, augmented reality, or blended reality, but like Philippe said, all these existing and new solutions have to be considered. I think that the NAAs, once we show that EASA has found a way for them to delist a little bit of the responsibility by following some guidance, they will join in. So to answer a little bit more shortly, we know that the French DGAC, French authority, German authority, and also Dutch authority are understanding what is going on, and they want to be part of it. And then the others will follow once they see that we're leading the way.
And do you then also see that is there a difference in the movement in this when we are comparing, let's say, recurrent training or type rating training versus non-type rated training, so training up until ATPL, when we also have use of different devices? Is there more movement there or less movement there? Do you have an opinion on this?
When you see actually the tasks that are required from a pilot when talking about the practical training and the practical exam, they're quite similar when you're talking about an ATPL exam or when you're talking about a type rating. We can mostly find them in Appendix 9 of Annex 1 of Part FCL. And there is a list of tasks. So these tasks have to be trained. They are trained, for most of them, in a full flight simulator. So the tasks are there and they are quite similar. What we need to do is to find a solution through the TNA and the process that was described by Anneke on how to get rid of doing everything in this high-end device and taking benefits of what the technology is bringing to us. There is no point, as we heard before, to sit in a full flight simulator, probably charge between 400 and 600 euro an hour just to get familiar on the communication panel. So this is what the point is. More than considering if it's for initial training, for initial ATPL, or for type rating, is to see if the training task and the training solution are adapted to carry on and to reach the training level that we need. I don't know if I'm really clear, but...
Frederick, if I may add to that.
Go ahead.
So this is an important point. Quite often we look at the regulation in parts. We look at the ATPL or we CPL or MPL, or we look at the type rating. ABLE is a way to look at training as a whole. It is not a solution for a part problem. It's a solution, hopefully, for the entire problem. We'll solve world hunger probably next, but all joking aside, this is not a regulatory part. This is about how we approach training. So ABLE is or should be possible to provide the same analysis for cabin crew training, for AMS training, for pilot training, in ATPL, but also in recurrent. It is a very broad approach to how we deal with training. And rather than from a technology point, we look at it, as Julien said, from on the pilot side, Appendix 9 to Part FCL. Those are the tasks. Those tasks are quite well identified, and they are part of the type rating training, but they're also part of the recurrent training. So ABLE is not only covering the ATP or not only covering the type rating, it's covering the whole slew of training that needs to take place in a career. And therefore, the use of the new devices, whatever innovations they are, should be assessed for the entirety of a pilot or a maintainer's career, and not only for the initial task only.
Makes sense. So it does show this broader applicability, and that was, I think, also a question from Luca Kobayashi here, is that could this also apply to cabin crew training, and the principles apply universally, pretty much. Of course, the regulations will have to, of course, allow that in all those different areas, if I understand you correctly. Yeah. So this actually is another question also that came up, and it's interesting for Ernst. Ernst, if you look back on the experiences that you've had, and maybe not only with this VR trainer, but also with other developments at KLM, what are your experiences with respect to trainee enthusiasm? And are there maybe generational differences? How is this received on the training end by the trainee?
Yeah, it's a very interesting point, Frederick. Within KLM City Hopper, we have a relatively young group of pilots. And we've really just started with releasing and training with this virtual reality headset. The general enthusiasm is very high. For now, we give a general introduction to people face to face about how to use the VR headset. And of course, it's a completely new technology that people have to learn to work with. But the moment they put on the headset, the first thing they say is, wow, this is amazing. And I really feel that I'm in a real cockpit. And I've even had candidates tell me that the controllers that they use, one of them was trying to leave them on the pedestal behind him, dropped them, and they actually dropped to the floor, completely forgetting that there was no pedestal next to him. So enthusiasm is very high. On the other hand, we do have to note that, and I think I completely agree with Captain Philip Adrian there, VR still is a black box, even for us. We're still developing what all the possible technology and the possible steps we can use it for are in there. Like I indicated, what can we do with voice control? We'll have to find out, and we'll have to see if that brings a certain fidelity towards the VR headset that we can then use for, of course, the benefit of the candidate. Looking to older generations, we will have to see, but I think in general, we use VR in different parts of the company as well. And people generally respond very enthusiastic on what we do.
That's, of course, promising and also very important, because I suppose the buy-in of the end user is going to be one of these things that's going to drive the success, next to, of course, a solid design. And it's also a segue into a question that I have for Andy Mitchell. Andy, is your microphone working this time? Should we just double check?
I hope so. How's that?
Loud and clear. So Andy, for you, actually an interesting question from more of a technological point of view. Like Ernst had indicated, VR is a black box, and of course there's a lot of possibilities coming up. Do you have any tips or thoughts with respect to how what the challenges that this presents, especially when we look into data privacy, data protection in these digital technologies? Because EASA has also indicated, or at least there are possible new regulations with respect to these privacy issues. What's your perspective on that?
Yeah, it's a great question, Frederick. I'll just go back to to begin to answer that. I'll go back to the previous question just to maybe input on that as well, just quickly. One thing I think we need to avoid as we go forward into new technology is always getting very anchored on the hardware and thinking, oh, this is a VR solution, this is an AR solution. Where we are with technology now is we're actually in a position where we can really interchange the technologies, both software and hardware, really easily. And so we should always be thinking about the fact that there might be a solution which works actually in both, and it would work in VR, AR, on iPads, and whatever comes in the future. We mentioned already, we don't know what's going to happen in the future. Philip said already, we need to be thinking about the pilot's entire career. Well, when we some of us come up towards retirement in, say, maybe longer than others, but say in 10, 20, 30 years or so, we're going to be in a position where the technology will be completely different. And we need to bear in mind that there is this interchangeable nature between hardware and software. Going on to your question there, quickly about data security and that sort of element and the challenges around that. Yeah, I mean, it's something which we need to be very, very cautious about as we move into new technology. Any move towards extracting or saving personal data, training data, that's a real minefield. We need to be very careful about that, especially if we want to get into things like gamification and feeding back to pilots and cabin crew how they're doing. We're going to start getting into saving data. If you were going out in the market to look for implementing ABLE, the things you're going to want to think about are things like GDPR compliance. I mean, that's a legality now. If you look at some of the airlines recently who have failed to live up to GDPR, they've had some very large financial hits because of that. And obviously, reputational, it's obviously a big issue too. And really what you're looking at is things, and Arnika mentioned this earlier, the idea of ISO 27001 is the data information security standard. Companies can be certified to that, and that really means you're in safe hands in terms of knowing you're doing a good job about cybersecurity as we go forwards. The final point to make, I think, as well, is from the point of build quality, you know, traditional simulator devices, very easy to know if a simulator is being built or not. If a switch falls off in a flight deck, you know that it's happened, you know it's not being built very well, and you can fix it. But software is different, and you don't know so much about how the software is being built underneath. So again, if you're going out to think about building a solution yourself as an airline ATO, or going to engage with a partnership, think about things like you want to hear words like test-driven development, agile, these sort of best practice terms that you'd hear, you know, Google and Facebook using, which are really like the benchmark in how we should build going forwards. It means things are being built with really robust tests in place on short sprint cycles. That mean you get great user feedback and very short cycles to course correct in terms of implementing feedback as well. So yeah, my takeaways would be those three things. Software, hardware is interchangeable, and it will be more so as we go forwards. Information security, ISO 27001 is going to be almost a necessity as we go forwards, and think about software build quality and how you can ensure that as well.
Thank you, Andy. So to close off, there's one last question. We're running a little over time, but I think it's an interesting question. And I think it's one that we can also introduce our last panel member who hasn't been able to turn on his webcam, but he should be there, and that is for Francisco Arenas Alvarino. And the question is actually, does the ABLE concept apply differently or easily or more difficult when we compare task-based training versus competency-based training? Because this is, of course, a new type of training that's also being introduced under EBT and PL, and in the future also, of course, for type qualifications. Is there a difference, Francisco, in how this would apply for this training or more classic training?
Hello, everybody. Just a voice check. Can you hear me well? Okay, thanks. It's a very interesting question, and the idea of ABLE when we started in 2016 with the competency-based training and EBT and everything, you know, with Anneke, this was the idea that it wouldn't be a problem to apply this concept in competency-based training. I think Anneke did a wonderful job with the capable process. For those that are not familiar, maybe another in a document or another session we can discuss. The capable process already embedded this competency-based training idea, and I think is fully applicable, and ABLE can be used both in a task-based oriented program like ATQP or AQP in the US, and as well a competency-based training program like EBT, or you know, other training programs based on competencies. So back to you. I hope it answers more or less your question.
Yes, it does. Thank you for closing with that, Francisco. We've covered a lot of different grounds also with these questions. I think we need to close at this point in time. We're 4 minutes over time. I'd like to thank you, the speakers on the panels. For first off, I'd like to thank Philip, Andy, Anneke, Julien, Ernst, and Francisco for their time and for their attention here. And also thank you for the efforts that you've been doing also outside of this webinar to make this a reality. I think these are all thought leaders, and I'm very happy to work with them. I'd like to close the webinar with also a thank you to all the attendees. A lot of thanks coming in from the audience, so appreciate that very much. If you have any questions on the matter, also now, or questions that come up later, reach out. You can reach out to capable@nlr.nl. You can also, of course, reach out to any of the panel members if you're familiar with them, but this is also a central point where you can reach out to. The webinar is recorded. We will make it also available via the same website where you can sign in on. More information on that will follow soon. Lastly, we also want to learn from you what the things are that will make a capable success in the industry. We might follow up with a small questionnaire to understand how it can best serve the industry. So that might come in as well, and we'd be very grateful for your insights that will help this effort move forward more effectively. Thank you all very much. Stay safe, enjoy the remaining of 2020, and we hope to see you soon.